Hello, welcome to my demo video. In this it is my demo 6. Demo 6. In this demo, I will be talking about RSA, RSA Public and Private Security, and what we will be doing is first we will see what is RSA and how we can apply it into our project, and then we will be understanding it step by step, and we will be creating our public and private key and adding it to trusted provider service, the project we have. Okay, so let's see what RSA is. So RSA, it is a widely used public key crypto system that enables secure data transmission and digital signature over insecure networks. So for so we can say it like we have this payment service. Okay, we can call it pay. Let me increase the font size here. Okay, pay 48, pay payment yeah, service. Okay, we'll be having this payment service here, and then we will be having, I guess, trustly provider service. Trustly, just right, trustly here. TRUS, the font size again. I can write TRUS here, right, trustly here, and let me grab this. So this is our payment service and this is Trustly. So what does a payment service will be having is uh, a, private key, private key and a public key, and same Trustly. Let me search where is the button. I get this. Copy this. Paste it here. So Trustly will be also having a private key and a public key. So let me show you how this key look like. See, this we have this Trustly website. Here we can see in authentication. We have this. We use a secure signature to secure authenticity and data integrity for communicating with trusted APIs. For that, we have trusted providers with public key. Trusted public key. This is trusted public key. It looks like this, and also it will be having its private key, which they have not shown us. Okay. So after that, what we have to do is go here, creating the key. Okay, uh, the hash key. Then generate RSA key pair. Sender and receiver each generate their own RSA key pair. Okay, public and private. Sender will be having public key and private key. Receiver will be also having public key and private key. Both will be different. They will exchange the public keys. They will not exchange their private key, but they will exchange their public key. Okay. Sender shares their public key with the receiver, and receiver will be sharing his public key with the sender. So, sender will be doing is he will be preparing the JSON request. So here's our sender is payment service. So what payment service will be doing is it will create the JSON data. The sender prepares the JSON request with the required data like this. We have this example. It will prepare a JSON data like this. So payment service. So we will be having this message. Okay, I guess. Okay, with the font size. Okay. In this payment service, payment payment service will first it will get this message JSON, and then what it will be doing is it will generate digital signature. How it will generate? First, it will hash the JSON, create a hash of JSON data using the hash function SHA-256. We already have seen this SHA-256 hash function. So what it will be doing is it will be converting this into a hash function. Okay. Okay. Using any of this hash function, it will be creating JSH hash 256. And then after doing this, what it will be doing, like we will be having value like this, equal to example hash. So let me add this. Then after that it will encrypt the hash function and encrypt the hash function with the sender's private key to create the digital signature. As we see here, payment service will be having its private key and public key. So what it will be doing is it will be then hashing this hashed JSON data. It was JSON. This hashed JSON into this hashed JSON. It will be hashing it once again and creating what it will create is it will create the digital signature. Okay, so we will be having some signature after this. So let me write signature DIGITR digital signature. Okay, so it will be creating some digital signature, and after that what it will be doing is it will be uh, it will attach the signature, attach the digital signature to JSON request like this. Okay, I'm going to increase the font size. So what it did is first we had this JSON message, then we hashed it, and after hashing we got this digital signature. And what we did is we added this with okay this digital signature into our JSON request. See, we have this signature and we have this hashed message. And after doing this, what doing is sending the JSON request. Uh, it will send the data, the sender sends the JSON request along with the digital signature to the receiver. It will be sending this data to the receiver. And here the receiver will be trusted provider service. Uh, we have here this trusted. It will be sending the request okay, from payment service to the trusted provider. It will be sending a request like this. Okay, and request will be having uh, this key. this JSON data. With message and the signature what we made. Okay. Then here in trustee, what it will be happening is okay. After going to trustee, may zoom out a little bit. Select this. Okay. After payment system, we will be having trustee here. Yeah, trustee, trustee. So this here it will receive the same message. Uh, this message. Okay. After receiving this message, what trustee will be doing is uh, the receiving and it will receive and verify the JSON this trustee. What it will be doing is it will be uh, will receive and verify the JSON request. So how it will verify? The receiver received the JSON request with attached signature like this. We already talked about and extract the data and signature separate. Separates the data and the digital signature. Example this. Okay, so after here, what it will be doing is it will be separating this. So after this, it will be separating this. Okay, it will be separating this message and this signature. Okay, what we had this we had this message and the signature. After we, it will create a hash of the received JSON data using the same function which the sender our payment service did. It hashed. So we will just copying this from here. And copy this, paste it here. After doing this step, after separating them, uh, it will has this JSON data, and after that, this JSON data looks like something like this after hashing. Okay, it's same like this we made earlier, and after that, what it will be doing is it will decrypt the received digital signature using which the sender provided us using the sender's public key. So, which will be doing is it will also be sending us the public key. So here they will provide us with the public key. The same public key of which private key they used to has this digital signature. So they will be sending us, and what we will be doing here is after this we will be decrypting that signature and using that public key. And what we will be getting is we will be getting a hash. So we will be getting another hash after 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 decrypting this signature. So let's copy um, here. What we will be doing is we will be decrypting. Okay, C R A P T decrypt. Okay, it will be decrypt and it will give us this hash. same. Uh, it will provide us this hash function, which we earlier had in payment service. Okay, so we will be pasting it here, and what hash function we made is like this. So our hash key was, let me erase this one. This was our hash, and this what we got from after decrypting the signature by right, decrypting with the public key of sender. Okay, decrypt with the public key of sender, we will get this, and after and these two steps, what we'll be doing is we will be comparing these two, and after comparison, okay, we will be comparing these both, like compare the decrypted hash with the generated hash from the received JSON, and if this compare decrypted hash and generated hash is the data is authentic and unaltered. If it is not, then it has been compromised. So let's see the summary. In summary of flow, sender it will first generate the RSA key pair, then create the JSON data, and then it will be it hashes the JSON data and encrypts the hash with the private key to create a digital signature. After that, it attaches the digital signature to the JSON data and sends the JSON data with the signature to the receiver. And what receiver does is receiver receives the JSON data with digital signature and extracts and hashes the um, JSON data, and then after it decrypts the signature using sender's public key, which this sender will be sending along with the data, and will be and compare the decrypted hash with the hash of the received JSON. And after doing this, it will validate the authenticity and integrity of the JSON data comparison. If the uh, decrypted hash and generated hash is equal, then it is authentic, and if it lost, that it is not authentic, or we can say the data has been compromised. So how we can implement this is we have this trusted provider service, and they have given us this code to generate our public and private key. So what we can do is, like I have this Windows, so I have to install this OpenSSL. We have this website. So we have this website. I will be writing here OpenSSL. So this is the website. From here, Windows user can download their exe file and install it. After installing, what we have to do is we have to open this command prompt with OpenSSL command and write this command over here. Let me move to the folders, cd, gscat, desktop, and after that mk uh, key generated generated key key pair, and after that cd key pair. And I will be writing this command, so it will generate us with private key and this public key and this command. After executing this, it will generate us with uh, public key. Let's see ls. We have here, okay, we have this private PEM, private.pem, and public.pem files. Okay. After this, what we have, they will here they generated. Right. So they have this begin private key and private key. This is my private key, and this will be my public. That's good. Public key will be also like this. Uh, it is stopped responding. Let's close this. What we will do is we got the our public key and private key. After that, what we have to do is they have given us this whole code and this JSON data. So this JSON data of code, what it will be doing is it will take this as an input, this JSON data, and make a serialized string like this. And after that, they will be making the secret key, or what we know it was they will generate signature. Okay. So for that, we have to just copy this code and go to ChatGPT and ask him for change this code into Java as we are using. So here we have this payment controller project. This is our payment provider project, and this one is our trusted provider. Okay. And in payment provider, what we will be doing is in our this service node initialization, we're going to set this. We will see implementation. We have here HTTP request and HTTP request. We have feedback request. Here we will be inside the code. So here we are using RSA service and RSA service. Okay. Okay. Here we are using this RSA dot read private key from here, and what it is doing is it is reading the private key which we have in this location in our source file. And here you can see in our source file we have this ecom private dot pem. We have private dot pem somewhere here. Okay. This is our private key, and after using this read dot private key, what we are doing is uh, we have this. Okay. We are making the signature from here RSA dot sum. So let's open this file. Okay. We have lots of functions over here. We have this main method here. We have this. We have some functions like serialized data. It is being used to serialize the data, and we have this parse to JSON function also here. We have this read private key function, read public key function, and we have this get the private key, and we have this function word sign. It will be generating the signature, and then we have this verify function. It will verify whether the signature and the data has been compromised or not. So it will be providing us with boolean value true or false. So after this, into our request processor, we have this RSA service. RSA service, we are reading the private key, and after reading the private key, we are signing the signature, and after signing the signature, we are just printing out the signature over here, and in params, we are giving the signature, and after that giving signature, we will be sending request to the trust service from this HTTP request. We are providing them with the URL and the request body and the method type. It is post, and the request body contains JSON string which contains this deported request, and request will contains our params, and params contains the signature and UUID and the data. So after that, when we hit this request, what it does it will be so the URL will be of Trustly. So we have this Trustly code. Trustly will be having its own private key and public key, and here they will be having functions to verify and the same. So if they have the same function or not, RSA into service, we have this. So they will be having their own function here or own method. So what we will be doing is first we will be this Trustly project, which is code provider, and sprint go run skip test and run, and then we will also be running this our payment provider run lead sprint go run. Okay, I guess they both have started. uh, this Trustly and this Trustly mock service and this mock service has been started, and provider it failed because let us see, let's run it once again. Run, sprint go skip test run. I guess it should run now. Okay, application started. So what we will be doing is uh, this payment provider it is into running in port number 8083, and this what it was, this other our Trustly Mark service. It is running in Tomcat 8084, and so we will. So that's why we have written this over here into our request processor 8084 payment initiate. Okay. So after that we will by opening our Postman service. Here we have written the 8083, but it will be 8080. Okay, 8083. We will be sending the request. So we send the request successfully, and the Trustly service returned the response like this. It made the directed URL, so we can just follow the link. Okay, something like this, have success and failure. Okay, so if we change the data, so this is all we did here. First, we made this message and hashed it. After that, added digital signature and sent it with the public key to the Trustly service, and Trustly service did all the methods to verify. And after verifying successfully, what it does, did it is return back the response. Sorry, the response with we have here response response with the redirected URL.